Okay, so we're going to finish up here the last little bits about different type of bonding. So remember, a covalent or molecular bond is going to hold together nonmetals, but then what holds the nonmetals to each other is they can be held to each other. Um, this would probably be better if we said molecules. Probably need to fix that in my notes. The molecules are held to each other. And so I think I need to rephrase that real quick. The molecules are held to each other by one of the weaker forces, and those weaker forces are dispersion or London forces, but I'm just going to put dispersion. Dipole, oops, can't write, and or hydrogen bonds. Now, these are not strong, and they don't connect. They don't hold, for example, they don't hold nitrogen to hydrogen. They hold a whole bunch of ammonia molecules together in a liquid. And so there's going to be an attraction between different molecules. So this is more between molecules. So there'd be an attraction right there, that H bond, and then that would help a whole bunch of ammonia show up in a container of ammonia liquid, right? So it's going to have a whole bunch of particles in there. Properties. Nonmetals are going to traditionally have low melting points. I mean, a lot of them are already gases or liquids at room temperature. They're either going to be non or poor conductors, and they're often a gas and that's room temp right there, at room temperature. So nonmetals, it makes sense, right? Like when you look at the elements, you're like, these are gases and things. They shouldn't be super strong. Okay, now we haven't talked a lot about metallic bonding. It doesn't really come up in year one. But if you look at this picture, the metals are weird. They have delocalized electrons and they're just kind of floating around. So like these are just delocalized electrons, and see, they're in all kinds of different places, and they can move around. And so that's the key thing. And like, if you remember one thing about metals, you want to remember the concept of the delocalized electrons, the idea that metals have them. And so this is the book definition that you always get. So the definition for a metallic bond is you have cations. That's the positive. So this is a cation, right? So that's a cation or positive. So you have a cation in a sea of, so like, like it's floating in this sea or ocean or whatever, of mobile electrons, meaning it's kind of all of these cations have all of these electrons kind of swimming around. I didn't make this definition up. This is what they always give you. But the idea is that the pluses are surrounded by these minuses, and those minuses can move. And that's the thing. So metallic bonding, the thing about the metallic bonding is that the bond is pretty strong, but we can do things with metals like make them into wires. That's called ductile. We'll hammer them into shapes, malleable. We can push these electrons around because they're not stuck anywhere. And so the strength of a metallic bond is based upon how many electrons it has and the charge difference between the pluses and the minuses. Not that you need to know that. You really need to know about the delocalized electrons. So an alloy is when you take two metals and you put them together to kind of get a better version of both. And so if you look at this picture, you've got this is a metal here, and then this is a different metal. So we put them together, we get a better overall property. So like you can't find like stainless steel or brass on the periodic table. That's because they're combinations or alloys of things. Okay, but let's look at this chart. What do you need to know? Some metallic properties. This is what you need to know on the test. You need to know that metals are good conductors of electricity, good conductors of heat. Malleable, we can make them into shapes. Ductile, make them into wires. High melting points. Shiny. What is the Y for every single one of these is pretty much the same. And that's why it's so easy to get this right on a test. Why do they have good conducting electricity? Delocalized electrons. Why do they conduct heat well? Delocalized electrons. Why can you make them into shapes? Delocalized electrons. You guys start to see a pattern here, right? Like if you are asked a why question on the test, it's always going to be from the delocalized electrons. So try to remember some properties for the test and just be able to answer the why with the delocalized electrons, and you'll be fine on metallic bonding. There's usually like one question on a test. It's not usually particularly significant. All right, I think we're gonna move on. It says a few minutes here. And this is kind of the end of the session. So I'm going to kind of, I'm not going to move on to the notes. I'm going to pause the notes here. We're going to move on to the next section later. The next section is Born-Haber, and it's very different. It's kind of like Hess's law. So it's a math thing. So we're going to stop here, and we'll pick that one up on the next video.